Okay, in the last video I talked about dilations, reflections, and translations, and this video is going to be more about just dilations. So a dilation is basically just a stretching or a compressing. Okay, and as I mentioned in the previous video, it can be either from the x-axis or from the y-axis. If it's from the x-axis, that means you're grabbing it from these two ends, and you're stretching it from the x-axis. That's why it says from the x-axis. Or alternatively, you're compressing it towards the x-axis. That's what it means when it says from the x-axis. Okay, so dilation from the x-axis is stretching or compressing from the x-axis. That way. So for example, here we're told to dilate by a factor of 2 from the x-axis. So the first thing we know, it says from the x-axis. That means we're going to be stretching it that way. And then we need to look at the factor. It says the factor is 2. That means that we're going to be stretching it that way until it's twice the distance it was initially from the x-axis. So what that means is, if we take any point along this curve, yeah, let's take this point, okay, and we see how far away that point is from the x-axis. So the distance between this point and the x-axis is that, yeah? That line represents the distance between that point and this x-axis. It's saying dilate by a factor of 2. That means whatever this distance is, we're going to multiply it by 2. Okay? So the new distance is going to be twice the original distance. So it's going to be this red distance here. Okay? So this point will go over there. And we have to repeat this process in our minds with every single point on the graph. Okay? Let's take this point. Yep. So where will this point go to? Well, the distance from the x-axis is that, and we need to double the distance from the x-axis. So the new distance will be twice this. It will be somewhere here. Okay? So this point will go to there. Let's think about this point. So this point is right on the x-axis. So the distance between this point and the x-axis is just 0. So 0 times 2 is 0. So this point is not going to go anywhere. It's going to stay here. Same with this point here. Okay? Let's do 2 more, and then we'll sketch the whole curve. If you take this point here, the distance between this point and the x-axis is this green line. The dilation factor is 2, so we're going to multiply this distance by 2. Okay? And same with this side of the graph. If you take this point here, the distance from the x-axis is this green line, and we need to multiply this distance by 2 because we're stretching it until it's double the original length. Okay, so that's the new point. Overall, if we did this with every single point, we would get a graph that looks like something like this. Okay, so something like this. Okay, it's not perfect, but basically what we've done is we've stretched it twice. We've doubled the distance from the x-axis this way. So we've stretched it this way until it's sort of double the length. Okay, so that's why a dilation factor of 2, double the length from the x-axis. We're stretching it this way. If it was from the y-axis, we would be stretching it that way, but we'll see more examples of that further on. Another quick example here, dilate by a factor of a half from the x-axis. First thing we notice is from the x-axis, so we're going to be stretching it this way. But here, the factor is a half, so in fact we're not stretching it, we're compressing it. If the factor is less than 1, we're compressing it. Okay? So instead of stretching it this way, we're compressing it this way, towards the x-axis. So if we think of, once again, if we take any point, we see what's the distance between that point and the x-axis. Well, it's this green line here. The factor is a half. That means we need to halve that distance. So the new distance is going to be that red line there. So the point is going to go here. Repeat this for lots of points. Let's choose this point, let's choose this point, let's choose that point. Okay? So the distance between this point and the x-axis is that green line. Distance is going to be halved. That's the new distance, that's the new point. Okay, similarly, we're just halving the distances for each of these points and we're going to get a new line which looks something like this. I'm pretty proud of that. That's pretty straight. So that's going to be the new function after the dilation. In general, okay, if you have a dilation of a graph y is equal to f of x by a factor of a from the x-axis, or okay, in the y-axis. So from the x-axis. So we've been talking about dilations from the x-axis, okay? From the x-axis is the same as in the y-axis. Sometimes these notations will get interchanged, but I always find it more useful to think about it as in terms of from. So from the y-axis, that's the same thing as from the x-axis is the same as in the y-axis or in the y direction, okay? Because you can think about you're stretching it this way, so that's along, like it's parallel to the y-axis. That's why sometimes it says in the y direction, but stick with from the x-axis, okay? So in general, if you have a dilation by factor a from the x-axis, that means we're taking all the distances, we're taking each point on the graph, seeing what the distance is from the x-axis, and multiplying that distance by the factor, which is a. Okay? So multiplying that distance by a. We don't know what a is. It's just some arbitrary number. And we do that with every single point. So this is also multiplied by a. This is also multiplied by a. You know, all the points are multiplied by a. This distance is also multiplied by a. And then the new function we get will look something like, oh, I missed that point there. Just pretend it's going through the line, and it'll look like that. That's the red function is the new function. Okay. So in general, if you've got a function, if you dilate by a factor of a from the x-axis, your new equation is a times f of x. A is just a positive constant. Okay. A is the dilation factor, and the dilation factor is always positive. If there's a negative at the front, that means there's a reflection and a dilation, but here we're just dealing with dilations. So if you dilate y is equal to f of x by a factor of a from the x-axis, the new equation is a times f of x, okay? That's just a fact. You don't need to know why this is the case or where this comes from. For your curiosity, I will make a video about that and upload the link somewhere here. But as long as you understand this and you understand what's happening graphically, you'll be fine. Okay? So this has been, so we've looked at dilation from the x-axis. Now let's look at dilations from the y-axis. Okay? So if you have a dilation from the x-axis, sometimes they say it's in the y direction. Similarly, if you have a dilation from the y-axis, sometimes they say it's in the x direction. So if you swap from with in, you have to swap y with x, okay? But just think about it from the y-axis, because that helps tell you what's happening visually, okay? If it's from the y-axis, for example, if it says dilate by a factor of 2/3 from the y-axis, it means we're grabbing it from this end and pulling it from the y-axis. So we're pulling it this way, or we're compressing it towards the y-axis, okay? Because the factor here is less than 1, we're going to be compressing it. So again, this time it's from the y-axis, so we look at all the distances from the y-axis, okay? We look at this distance. So the distance between this point and the y-axis is this green line, and we need to multiply it by the factor. The factor is 2/3. So what's 2/3 of this green line? Well, that's 1/3. That'll be 2/3. It'll be about there. Yeah? So the new distance will be somewhere there. Okay? Let's do the same thing with another point. Let's do it with this point, and I'll also do it with this point. Okay? And this point, the distance from the y-axis is that green line. 2/3 of that distance is there. So that's the new point. Okay, similarly with this point on the left, distance from the y-axis, because it says from the y-axis. From the y-axis, the distance is that green line. 2/3 of that distance is that red line, and that point, that will be the new point there. So the new graph will look like that. It's just been compressed from the y-axis. Okay, it's just been pushed this way. Okay, one more example. Here we've been asked to dilate by a factor of 2 from the y-axis again. Okay? Okay, so from the y-axis, that means we're pulling this way, from the y-axis. So we're going to take every point here, every point, whatever the distance is, we're going to multiply that distance by 2. Okay? So twice that distance will be that, twice that distance will be that, twice of that distance will be approximately there, twice of that distance is approximately there. So these are our new points. Okay? And similarly, same thing for the other side. So what we will get as our new graph will be something like this. I'm just going to turn it around so I can draw it better on the other side. Okay, I messed that up slightly. That should be less pointy. But there you go. So dilation of factor 2 from the y-axis. That means you start from the y-axis and you stretch it two times in that direction. You multiply all the x values by 2. Okay? From the y-axis. Start from the y-axis, pull it in that direction until all the distances are twice of what they were before. Here the width has changed. The width is twice what it was before. Okay? Again, in general, if we have a function y is equal to f of x and we dilate it by a factor of a from the y-axis or in the x-axis, but only for now consider the froms, from the y-axis, if we dilate by a factor of a, then the new equation is f of 1 on a times x. Okay, this is different from what it was before. Before, here, this was for when you're dilating from the x-axis. If you this one. If you were dilating from the x-axis, then the new equation would, by a factor of a, then the new equation would be y is equal to a times f of x. But if it's from the y-axis, it is 1 on a, it is f of 1 on a times x. So two differences here. If it's from the y-axis, the factor is always inside the brackets. Here, it was outside the brackets, it's a times f of x. Here, it's f of 1 on a times x. And you always flip the factor when you're trying to get the equation. Okay, so if you have a dilation by factor of a from the y-axis, then your new equation will be f of 1 on a times x. Again, you don't need to know where this comes from, but for your curiosity, I will make another video in case you want to check that out. Okay, so this is what we've learned. This is a summary of what we've learned. If we have a dilation of factor a from the y-axis, then our new equation, if our old equation was y is equal to f of x, our new equation would be y is equal to f of 1 on ax. This is from the y-axis. Okay? If we had a dilation of factor a from the x-axis, then our new equation would be a times f of x. You just have to remember that. And let's look at an example. Let's say we're dilating this by a factor of 2 from the x-axis. Okay? Let's say a is equal to 2. Okay? Looks like a minus. There you go. A is equal to 2. If that makes it a bit clearer. So if we have y is equal to f of x, our new equation would be, I'll write y new. Y new would be f of 1 on 2x. So wherever there's an x, we replace it with 1 on 2x. So this becomes 1 on 2x all squared, which becomes 1 on 4x squared. Okay? So if we dilate the graph of y is equal to f of x by a factor of 2 from the x-axis, this is the equation we get. Okay? What happens if we dilate this graph by a factor of 2 from the y-axis? Okay? Again, from the y-axis, that means the new graph, the equation for the new graph will be f of 1 on the factor is 2, x. Okay, so wherever there's an x, we replace it by a half x. So our new equation becomes square root of a half x. Or maybe you'd like to express it as square root of x over 2. Same thing. Okay? Now we're going to from the x-axis. So if we have if we have the graph of, if we have y is equal to x squared and we're dilating by a factor of, let's say a is equal to 2 again, from the x-axis this time, then our new equation would be simply 2 times our old equation, so 2 times f of x, okay, which is equal to 2x squared. Easy. And if we had this function, if we had y is equal to x squared, and we were dilating that by a factor of 2 from the x-axis, then again, just multiplying it by 2. So y is equal to 2 times f of x, which is equal to 2 root x. Okay, I hope that makes a bit of sense, and I hope that helps you. If you're not sure, maybe go through the video again, and try and understand it. So I will make a video about where these two equations come from, and the link will be below. But as long as you remember this, remember that if you have a dilation of factor a from the y-axis, then you're stretching it from the y-axis, then you're stretching it that way, and the equation becomes this. And you remember that if you have a dilation of factor a from the x-axis, then you're stretching it this way, so not what's shown on this diagram, you're stretching it that way, and that's the equation. If you remember those things, then you'll be fine. You need to remember visually what this does, what these two things do, and you need to remember what these equations become. Okay?